Comparison between HFO and MGO. Welcome to this lecture on the comparison between heavy fuel oil, or HFO, and marine gas oil, commonly known as MGO. In the maritime industry, fuel choice is one of the most important factors affecting engine performance, operational efficiency, cost, and compliance with international regulations. HFO and MGO are the two main fuels used on ships today, and while they both serve the same basic purpose, they differ greatly in composition, handling requirements, emissions, and cost. Understanding these differences helps marine engineers, ship operators, and decision-makers choose the right fuel for each situation. The next slides, we will examine their properties, operational implications, environmental impacts, and regulatory context. By the end of this lecture, you will have a clear picture of the strengths and limitations of each fuel type, and how to balance performance, cost, and compliance when making fuel decisions. Lecture objectives. In this session, we have three main objectives. First, we will differentiate between HFO and MGO by looking at their composition, physical properties, applications, and environmental impact. Second, we will identify the key advantages and limitations of each fuel, exploring not only their technical features, but also their economic and regulatory implications. Finally, we will evaluate the operational requirements involved in handling these fuels, including pre-treatment, storage, and compliance with global environmental standards such as the IMO Sulfur Cap and MARPOL Annex VI. Together, these objectives will give you both a technical and practical understanding of how HFO and MGO are used in today's maritime industry. By the end, you should be able to assess which fuel is better suited for a specific operational context, and recognize the challenges ship operators face in balancing efficiency with environmental responsibility. Basic definitions. Let's begin with the basic definitions of the two fuels. Heavy fuel oil, or HFO, is a residual fuel derived from the refining process. It has high viscosity, contains heavy hydrocarbons, and often includes significant sulfur content. Because of these characteristics, HFO requires heating before it can be pumped in engines. In contrast, marine gas oil, or MGO, is a clean distillate fuel. It has low viscosity, lower sulfur content, and can be used directly without preheating. This makes it much easier to handle, especially in colder climates. While HFO has historically been the dominant fuel for large, long-haul ships due to lower cost, MGO is increasingly used in areas with strict emissions controls. These basic differences in composition and handling set the stage for their broader comparison in terms of efficiency, environmental impact, and compliance with regulation. Comparison table. Now let's compare HFO and MGO across several key features. HFO is a residual fuel with high viscosity, requiring heating to about 130 degrees Celsius before use, while MGO is a distillate fuel with low viscosity, usable at ambient conditions. HFO typically has a high sulfur content above 0.5%, whereas MGO contains less than 0.1% sulfur, making it much cleaner. In terms of density, HFO is heavier, while MGO is lighter and easier to handle. Energy content per volume is slightly higher in HFO, but MGO produces fewer harmful emissions, such as oxides and particulates. HFO can increase engine wear due to contaminants like cat fines and sludge, while MGO offers cleaner combustion with less wear. Cost per ton is lower for HFO, but MGO is more expensive. In practice, HFO powers main engines on long-haul ships, while MGO is preferred for auxiliary engines, smaller vessels, or when operating in emission control areas. Handling and operations. The handling requirements for HFO and MGO differ significantly. HFO must be stored and injected at high temperatures, typically around 130 degrees Celsius, to reduce its viscosity and allow proper flow. Before use, it requires pre-treatment, including separation, filtration, and purification, to remove impurities and reduce risks such as sludge formation or abrasive engine wear caused by cat fines. MGO, on the other hand, is much easier to handle. It can be stored and used at ambient temperatures, with no need for heating. This reduces maintenance requirements and makes it especially suitable for operations in cold climates. Additionally, MGO works efficiently with modern engines and is compatible with dual fuel systems. From an operational standpoint, this makes MGO more flexible and user-friendly, though its higher cost remains a limiting factor for widespread use in large ocean-going vessels. Environmental and regulatory context. From an environmental and regulatory perspective, the differences are critical. HFO is a high-emission fuel, producing significant greenhouse gases, sulfur oxides, and particulate matter to comply with the IMO's global sulfur cap of 0.5%. Ships burning HFO must switch to low-sulfur blends or install exhaust gas cleaning systems, known as scrubbers. In emission control areas, HFO is prohibited unless scrubbers are fitted. MGO, by contrast, contains less than 0.1% sulfur and burns cleanly, producing lower emissions and supporting full compliance with MARPOL Annex regulations. This makes it the preferred fuel in ECAs and for operators seeking to minimize their environmental footprint. While HFO may still be economical for long-haul voyages, MGO aligns better with modern environmental standards and is increasingly seen as a future-ready marine fuel. Interactive quiz. Let's test your understanding with a quick quiz. First, which fuel requires preheating before it can be used? The correct answer is HFO, since its viscosity is too high at ambient temperatures. Second, why is MGO considered more environmentally friendly? The answer is because it has much lower sulfur content, resulting in cleaner combustion and reduced emissions. Finally, which fuel can be used in emission control areas without the need for scrubbers? The correct answer is MGO, as it already complies with strict sulfur limits. These questions highlight the key operational and regulatory differences between the two fuels. They show how fuel choice is not only about cost but also about safety, maintenance, and environmental compliance. Additional resources. For further study, I recommend several key resources. The DNV HFO versus MGO operational study provides detailed insights into the practical challenges of switching between these fuels. The ISO 8217 Fuel Grades Guide offers technical standards for marine fuels, helping engineers understand quality specifications. Finally, ExxonMobil's Fuel Switching Handbook is a valuable reference for ship operators, giving practical advice on transitioning between HFO and MGO safely and efficiently. These resources complement the material we've covered in this lecture, providing deeper technical details and case studies. I encourage you to explore them to reinforce your understanding and apply the concepts effectively in real-world maritime operations. Summary. Let's summarize what we've learned. Choosing between HFO and MGO has direct implications for engine performance, operational costs, and regulatory compliance. HFO is a high-energy, lower-cost fuel but comes with higher emissions, handling challenges, and maintenance requirements. MGO is cleaner, easier, and fully compliant with emissions regulations, but its cost is significantly higher. With stricter sulfur regulations in place, ship operators must balance efficiency and environmental responsibility. The choice often depends on voyage length, regulatory zones, and ship design. Understanding these differences equips marine engineers and engine makers to make informed fuel strategies that optimize both performance and compliance. Closing. With this, we conclude our lecture on the comparison between heavy fuel oil and marine gas oil. We have examined their composition, properties, handling requirements, environmental impacts, and regulatory contexts. As the maritime industry continues to face stricter emissions standards and rising fuel costs, the choice between HFO and MGO will remain an important operational decision. Remember, each fuel comes with advantages and limitations, and the best choice depends on the balance between cost, performance, and compliance. Thank you for your attention, and I wish you continued success in your studies and professional journey. With my best regards, Dr. Sam Atafi.